Thank you for joining us. We're happy to have you.
Nice to meet you. Yeah, thanks for having me here.
I'm really excited to talk about your paper. It's entitled Curiosity-Driven Red-Teaming for LLMs. Before we get into the specifics of your paper, though, I'm interested in learning more about your journey into this space and what drives your interest in red teaming in particular.
What drive me to start working on machine learning is a robotic context in my undergraduate study. So I learned reinforcement learning during that context. There was a robotic context hosted by NVIDIA. So we were training the robot to, kind of navigate in the maze on a racing track to avoid obstacles and following the track to the finishing line. And I get interested from this contest. And then later on, what drive me to red teaming is because the specific challenges in red teaming, which is exploration. So my favorite topic in reinforcement learning is exploration. It's about discovering needle in a haystack. And then that's a common problem in many engineering domains. Like if you want to find a good a program that successfully solve your issues, or maybe like in red teaming, you want to find the prompt that will trigger some unsafe response from the chatbot. But not many prompts will do so, right? So that's kind of finding needle in the haystack. And I'm particularly interested in using reinforcement learning to address this challenge.
LLMs, they're getting better and better. We're using them, we're seeing them more and more in various domains. Talk to us a little bit about the problem space, particularly around LLMs and chatbots generating misinformation and harmful content, and how that relates to the problem space of this paper.
Sure. So you can think of, LLM is very capable of doing many things as well. It can answer any daily questions, day-to-day questions, or math questions, writing articles, or solving software engineering issues, many things. But when you use LLM in those high-stake tasks, there could be a risk that the language model could make a mistake or generate misinformation, and then even those misinformation or wrong answer may not be common, but if that happened, that could cause significant expense or significant damaging to your either business or to your system. How to discover when the language model make a mistake is the problem tackled by red teaming. And then in general, you want to find those people use red teaming technique to discover the problems of the language models, and then kind of incorporate them into training data set so that they can train the model to not do so in the next iteration.
You're like red teaming, you're purposely trying to kind of elicit harmful responses or break something, right? There's different types of red teaming. You mentioned them in your paper. Right? Talk to us a little bit about the different types of red teaming that are out there.
Sure. So I think the most straightforward way is using human to red team the system, because you can language model is facing humans, right? So you could ask humans to design the prompt to try to trigger undesired response from the models, right? But this is going to be very time consuming, and probably also very expensive, right? Because you need to hire humans and then sit down in front of the computer, writing a bunch of a prompt, in the hope to discover something trigger language model to do wrong things. And that's why people start looking into automated red teaming. So I think perhaps the most easiest way is to paraphrase the existing prompt written by humans. There are many ways to paraphrase those existing prompts, right? But this doesn't, yield quite a good result, because paraphrasing doesn't significantly change the semantics, also the lexical structure of the prompt. So that's why people start looking into more sophisticated way of generating prompt, and that is using language model to write the prompt, triggering another language model to generate undesired response. And that's the most widely used approach in automated red teaming nowadays. For automated red teaming that use language model, there are still multiple different approaches. So I think perhaps the easiest one is to simply just prompt the language model to generate a prompt. Kind of you treat the language model like the proxy humans. You write
Hmm.
a prompt, ask it to write down some prompt that will provoke another model, something like this. Has been kind of a common baseline in many red teaming paper because that's the easiest way to do so. And people
Right.
find that this is not going to be useful, and that's why uh, later on people start looking at multiple different strategy. Like if maybe few shot learning, you incorporate some examples of a successful prompt that trigger undesired response into the red teaming language model. Hopefully, it will learn something from the examples you provide and generate something similar. Another way of purposing language model to perform red teaming is using reinforcement learning. And then why reinforcement learning here is a good idea is because reinforcement learning is known for discovering, some human unconceivable
Hmm.
patterns to trick or hack the systems. There are some famous examples in deep reinforcement learning that in Atari, which is a video game that was usually for benchmarking reinforcement learning agent, they found that reinforcement learning agent can find the bugs in the game to cheat the score. And similarly, in red teaming, this capability is particularly important in red teaming because in red teaming, what we want is to find those prompts that human cannot conceive and
Right.
that can trigger undesired response. Yeah.
Right. If we had thought about it, we would have protected against it, right? It wouldn't have
Yeah.
happened. So yeah, that's interesting. So before we get into the curiosity driven red teaming, which is your approach, what are other methods that people use?
I think in general you can categorize them into maybe two ways. One, maybe let's start with reinforcement learning. So this way is very straightforward. You train the model to generate prompt, and then and then evaluate this prompt at another language model by producing the response using this prompt. Let's evaluate whether the response from this target language model is undesired or not, and then take the undesiredness as a reward for red teaming language model. This
Mhm.
is quite a very straightforward way, and then based on this approach, you can design many different ways of constructing the prompt for red teaming language model, because red teaming language model is also a language model. It needs some prompt you need some prompt to drive it, right? And
Right.
then there are a bunch of works discussing about how to construct this constructed red teaming prompt. Second approach is maybe through supervised fine tuning. You could take
Mhm.
some example prompt written by humans, and those prompts have shown to be able to trigger unsafe response from the target language model. So the idea here is that they train the language model to imitate those prompts.
Mhm.
In the hope that they can generate something similar out from those data sets. And the third approach, as I mentioned before, is kind of few-shot learning. You prepare some examples, but you don't use those examples to train the language model. Instead, you simply just take those examples, put them into the prompt of the red teaming language model, and then hopefully they can use so-called in-context learning to generate a response similar to the examples you provide in the prompt.
Okay.
These are sort of a free approach. Now, what's the difference between my curiosity-driven approach and this approach? So, among this, all the approach I mentioned, they mostly focus on the quality of the prompt, which means the quality here means the likelihood that they can trigger unsafe response from the target language model. But
Hmm.
what they miss is the diversity of those prompts. So you can think of the one possible solution for reinforcement learning red teaming approach that was trained only by the reward from the unsafe response can be consistently generating the same prompt over and over again and get the unsafe response from the target language model. Because
Hmm.
this way, they can maximize the expected reward and then maximize the chance, which means they can maximize the chance to get the undesired, unsafe response from the target language models, right? And then they are happy, and then the reinforcement learning agent will be happy because they get a high reward.
Mm.
But this is not what we want in red teaming, because what we desire for is a wide, extensive range of prompt that can trigger unsafe response, not just single point in this distribution.
Let me test my understanding here. So one of the limitations is the way in which reinforcement learning works itself. It has a propensity to create a lack of diversity in the prompts.
Pretty much, but the other approach, like a few shot approach and also supervised learning approach, could also have the same issue, because in those approach were not incentivized for generating diverse prompt as well.
Okay, so tell us about your approach. How did you address that?
The way we address that is to, it's also kind of simple. You just directly incentivize the model to produce diverse prompt. So how do we do
Okay.
this? So the reason why I named this approach as a curiosity-driven red teaming is because we want the model to be curious
Hmm.
about a prompt that has not been generated before. Intuitively, you can think of now you are asking the model to generate a prompt that will trigger unsafe response, but after a prompt has been generated before, you will not give the reward to the model next time. So it will be pushed to generate more and more new prompt through the process of interacting with the target language models, right? Because you will not get any reward by repeating the prompt you have discovered before. But how do you? But the tricky thing is that how do you define two prompts are similar? I mean, because the difference between two prompts are the curiosities we reward the agent, right? But the problem is that the prompt is a very long string, right? How do you determine if two strings are similar enough to be the same, to be considered as the same prompt?
Hmm.
So yeah, here it is a tricky question, but here we found out that you could easily construct a nice curiosity signals by simply just use the sentence embedding model and also BLUE score. BLUE score is a classic text similarity metric used by natural language processing field, and then we combine both BLUE score and the sentence embedding similarity as the reward for the reinforcement learning agent. And now, if you train reinforcement learning agent with this free reward, the quality reward from triggering unsafe response, and the BLUE score reward and the sentence embedding reward by generating diverse prompt that is distinct from the previously generated prompt, then the reinforcement learning model will be incentivized to generate new prompt at every step during interaction with the target language model, and that's why we can achieve better diversity and also quality.
And you call these are the novelty rewards
Yeah.
in the paper. Now, so tell us exactly what is gram modeling and what is sentence, like what are you looking at when you're looking at gram modeling and sentence embedding?
So graph modeling is kind of explaining that will take some time, but the overall idea is that you take the prefix matching between
Okay.
two sentences as the similarity between them. So you can think of it, if you have two sentences, this is an apple and this is an orange, something like this, and you can split them into three words, right?
Hmm.
And then in grid modeling, you can take the this prefix and then calculate the difference between the words in two sentences.
Okay.
Yeah, yeah. That's the kind of a high level ideas. But for sentence embedding, it's a distance in the embeddings vectors learned by another model. So how we do this? So they train. There are a bunch of pre-trained sentence embedding models out there. They were pre-trained on a large scale data set of the text. They can know the semantics of each sentence, and then they will project two sentences with similar semantics into a similar point in the vector space.
Okay.
So if two sentences are semantically similar, then their embedding distance will also be very small. And then if you can this way you can measure the semantic difference between two sentences, right? So then we can take this distance as part of the reward to as for reinforcement learning agent, so that you can encourage it to generate the sentence. They are very different from the previous one.
Some previous ones. Okay. All right. Now, what experiments did you set up?
We set up many experiments, and so I think the easiest one is that we take the movie reviews. That's kind of a most toy. That's a toy experiment to showcase the ideas. We take the
Hmm.
movie review prefix from IMDb, and we are trying to construct another prefix that will make another language model to generate toxic
Right.
toxic completion of this review. This is a kind of a most simple toy setting in language model. Now, a more practical setting is in the chatbot settings. We train our red-teaming model to generate the instructions for a chatbot language model to respond, and then we take the toxicity of the response from the target language model as the reward to evaluate and also train our red-teaming model. We evaluate on open source models and also closed source models like ChatGPT. By the time we are doing this experiment, there were only like GPT 3.5. And now it's progressing very fast now. Yeah, and we also evaluate on Llama model. Llama 2 was the model we were using last year. Yeah.
And what were the results? Were you surprised by any?
So what we surprised, I think the most surprising result are twofold, I would say. First of all, our method does not only improve the diversity of the prompt. As I mentioned before, the key distinction between our method and the others are that our method incentivize the model to generate diverse prompt, right? While the others are not. But we found that by incentivizing diversity, we also get higher quality, which means that we among the same amount of the over the same amount of a prompt we generate, we can achieve higher percentage of the prompt that can trigger unsafe responses, comparing with
Okay.
the other method, which means that incentivizing the diversity also help the red teaming model to discover the prompt that can trigger unsafe response. And that is highly aligned to the research interest that I mentioned before in the beginning exploration, because incentivizing the diversity can surely help you finding the needle in the haystack more easily, right? Because you can think of it this way. I mean, if you are looking for a needle in the haystack by only rewarding yourself about finding the needles, then you will never be able to navigate in the haystack efficiently, right? But if you recognize the corners you visited before in the haystack, and then you keep exploring new ones while searching for the needle, you are making use of your time more efficiently, right? Because you are not repeatedly search the previous space, and that's why uh, our approach also improve the quality of the red teaming. And now the second interesting result I want to mention is that the result we found is actually, I mean, the prompt we found is actually quite natural. So there was why is this interesting is because there have been many results reporting that reinforcement learning could easily hack the reward function and make the generated text very unnatural. Like
Hmm.
it will probably just keep generating k k k k k k k g g g g g
Right.
g something like this. This can still hack the reward function pretty well because the reward function here is also toxicity classifiers, right? What's surprising us is that our reinforcement learning model is actually generating quite a natural text. And
Hmm.
those text can actually trigger unsafe response from the target language model, even those that are looking quite benign, and but the language model itself, but the target language model still generate quite a toxic response. There was some examples shown on the paper, but they may be too long, yeah, to show to go over them here.
Yeah, table one. I was just going to say, so you include some of those in. table one. So you're able to elicit these responses from LLMs that
Yeah.
fine-tuned with human preferences. What does the fact that you were able to do that tell us about the models themselves?
I think that the implication is that the human preference fine tuning is maybe not the perfect way to align the human preference. So I mean, because it seems to me that human preference fine tuning is about to, mathematically speaking, is maximizing the expected preference rewards, right? But maximizing the expected reward over what distribution? The distribution of the training data is going to be, highly affecting the preference tuning
Hmm.
results. And then those underrepresented users in the training data could have received those uncomfortable response from the language model. So I think, and then we can easily find those edge cases using our reinforcement learning technique. So I think the implication here is that we need another approach that is more agnostic to the distribution of the training data to prevent those undesired response from the language model. And what can we do about this problem with this data? I think one idea is that if we can keep doing this over multiple iterations, then what we can actually do is you can uh, formulate this as like a two-player games, right? The red teaming model is keep attacking the target language model, and the target language model gets evolved over time. So if we can reach a equilibrium where red teaming model is not able to discover any new prompt that will trigger unsafe response, and the target language model does not have any unsafe response, then I think that means you pretty much generate training data to cover all the possible prompts for the language model.
I'm just curious, is that how it works? Is then all of those prompts you stored and used to then train future models so that they don't produce those same responses?
So whether or not the model will be able to learn from those from the red teaming prompt we generate, that's another future questions. So
Okay.
even if you suppose consider this example, even if you generated a prompt that will trigger unsafe response and then you take those data for training your language model, and then you use some reward functions to ask to train the language model to not generate those undesired unsafe response anymore. It is still possible that the language model fix this issue and raise another issue. You fill up this hole, and then there's another hole coming up. And then that's kind of connected to the first point I mentioned. We should aim for some other approach. Basically, I think one of the major caveat of the preference fine tuning is that it is dependent on the training data distribution and also transformer training. You cannot guarantee that what information it forget or what information it
Hmm.
will memorize. So
Okay.
from teaming perspective, I will feel like the approach that is more formal method will be more reliable. Like if we can design kind of a safeguard or before we generate any response from the language model, and then this safeguard will kind of filtering out what kind of response are unsafe, are undesired, then I think it should be able to do a much better performance than simply just fine tuning the model with the human preference. Because
Right.
if we do this way, we can bring in a lot of the interpretability techniques that we can parse the response. I think I'm not the expert on that interpretability area, but personally feel this is a more promising way to go comparing with human preference fine tuning.
I'm curious about where red teaming sits in model development and in
Hmm.
businesses. Wouldn't it be better for the red teaming to exist outside of businesses of the makers of the models? Are the people that made the model or the businesses behind the models the same ones that are red teaming it?
I will say depends on the purpose.
Hmm.
So if we want to evaluate, or if we want to use red teaming as the way to generate more data for training our model to be safer, then I think doing it internally
Hmm.
is making more sense because internally you have access to your model's weight, right? So you
Right.
can make use of a much more information. Like you can take the advantage of the gradient information from the weight model weight and then discover the prompt that will trigger on safe response more easily, and then you can incorporate that into training data set and then make the model safer. That's for internal purpose. But for eval, I think there's another aspect. We could treat red teaming as a kind of an auditing procedure.
Right.
Yeah, so that should be done externally. Like you can think of the now if we want to propose a safety standard of of a language model, not necessarily just on misinformation, toxicity, something like this. Maybe it will be some like a policy compliance in your company or policy compliance in in some countries maybe.
Hmm.
Then you can have automated methods that will examine whether a third-party language model satisfy each criteria or not. Yeah, that was
Hmm.
external usage of this red teaming. Yeah.
And what are your thoughts on that? Like having an audit, like a mandatory auditing
Yeah.
entity?
I guess from a researcher perspective, I may not be able to comment too much, but what I'm envision is that if in the future there are a lot of language model makers or maybe agentic application makers, then there should be some safety standard like the safety standard we make in appliance, right? Some
Hmm.
electrical appliance. When it comes to that stage, I think there should be some auditing method to examine with how the language model react to each scenario. For example, there are many people using language model as the assistant, digital assistant nowadays, right? In like banking or airlines. We probably want to ensure that the language model we deploy is not going to violate some domain-specific policy. If we have a safety standard, then they can examine the safety of each language model, then this thing shouldn't even happen because
Right.
yeah, this language model will not even pass the standard and go into the product.
Okay, so going back into your paper,
Yeah.
you talk a little bit about like the reward terms
Yeah.
and the effects of them. So tell us a little bit about that.
I think the we have the quality reward, which is the whether or not we trigger toxic response or unsafe response, right? Secondly, we also have an entropy bonus. Entropy bonus was purposed for encouraging the diversity of the prompt, and the
Okay.
entropy bonus was you can think of entropy is like a measure of the randomness of the model's output distribution.
Okay.
So if this bonus was maximized, then it means that the models is generating a very random result. This can which means the output will be more diverse. And this was also a very classic technique used in deep reinforcement learning, but by the time we published the paper, there was no usage in language model yet. Yeah, which is
Okay.
funny. And the blue score reward I mentioned before, that was an n-grain kind of an n-grain similarity between two sentences, and we use that similarity to encourage diversity. And this sentence embedding reward.
Right.
Yeah, yeah.
So what are the limitations of this study? What?
So I think the one limitation of the study was that we didn't test in multi-turn conversation setting. All of the experiments we set up in the paper was conducted in a single turn conversation. So I think you must use ChatGPT before, and you can interact with the ChatGPT in many turns, right? You send out one request, and the ChatGPT answers you, and you send out another request again, right? This is
Mhm.
like a multiple interactive conversations, right? But in our paper, the conversation only goes one round. Like the model generate
Mm.
a prompt, target model answers, and the answers get evaluated. The reason we didn't do multi-turn evaluation was because of the infrastructure limitation.
Mhm.
To evaluate that multi-turn conversation, that will cost a significant amount of training time. Yeah.
Do you have hypotheses on how multi-turn conversations would uh, affect the red teaming model?
So actually, there were some follow-up papers on red teaming community showing that multi-turn conversation is actually an easier problem for red teamer.
Mm.
Yeah, because the language model tended to it could be easily fooled in multi-turn conversation settings. So there are
Mhm.
there's a famous example. So in a single turn conversation setting, there's no way to ask the language model to make a bump. But if
Right.
you extend this conversation into multiple turns, for example, you start a question like, "Hey, I am studying a chemistry class, and here's the bump recipe," and they explain the usage of each one. And then the previous few turns of a conversation looks like the question answering in chemistry class. And then in the final turn of a conversation, you turn the question into, now can you make a one? Then
Right.
then you get a bump recipe very indirectly, right? You make a tutorial.
Interesting. Okay, so I have to ask, you're training an LLM essentially, or multiple models
Yeah,
to red team another model.
yeah.
It makes sense from a practicality standpoint, from a maybe a exploration standpoint, from the diversity standpoint. What are some of the risks? Like, can we really trust AI to red team AI?
Oh, that's a great question, and I think that is very relevant to the safety compliance questions I discussed before. Well, to the question, can we trust AI to red team AI? I guess you don't have any guarantee to say that AI covers every possible prompt that another AI model could encounter. But I think similarly for human red teaming, that is also the same issue. That there's also the
Right.
same issues, right? You could never guarantee that you exhaustively test all the test cases for your systems, right? And I think this is also very similar to many engineering safety criteria. I think, for example, like in many of our systems, we write unit test to test our program, but those unit tests we can calculate the coverage into over our programs, but we will never be able to know that whether we cover every possible combination of those inputs. So we will never know if we test all those cases before. So back to the question, can we trust AI to red teaming AI? I think if we can trust human to red team AI, then I think logically we should trust the AI to red team AI as well, because I think it seems to me both are imperfect. Yeah,
Hmm.
and
Yeah.
then what we can only aim for is to make it better
Better.
and cover more and more things, and hopefully the safety will be improving over generations.
Is there a possibility for generative modeling with red teaming, considering like just by the nature of reinforcement learning, you are limited, even if you're producing all of this training data, you're still limited by the training data. What is there an potential for generative models to assist with red teaming or creating red teaming models or
Oh, that's a good question. So there's an obvious path here. Like we can use generative model to generate much more scenarios for the
Mhm.
retraining models to try to produce the prompt. Okay, so one example in one limitation in my previous paper was that I only consider the chatbot conversation settings. So my models were only trained to generate the prompt that is likely to happen in daily conversation with the chatbot. Like a
Hmm.
pretty much like easy question answering problem. But there are multiple domains I miss, right? Like for example, I didn't consider math solving scenario. I didn't consider software pro coding scenarios. In those scenarios, there could be also be some undesired response over there, right? But I didn't cover. And that's where generative AI can help, because if we can use generative AI to generate diverse domains for the model to learn, then we can increase the coverage of the domains that our red team model can
Right.
operate. Yeah.
All right. So then for future work, both related to this work and for yourself, what do you have coming up? Any publications to look forward to?
So we did have a follow-up work of this. So, but it was not about methodology wise. So we were looking for another type of a harm. So in chatbot settings, the undesired response is like a toxic response or some misinformations, right? But these are not physical harms yet, right?
Right.
But nowadays, people have been looking into integrating language model to agentic systems. They can interact with the physical world, right? Like robots or coding agent or maybe digital assistant. So when we integrate language model to interact with the physical world, there are multiple different kinds of harms that we should be considering. First of all, if you use language, there are some papers using language model to control the robot, right? But what if your language model make the mistake, misinterpret your instruction and demonstrate unsafe behavior? And that's why in our follow-up work, we are considering, can we use the same red teaming procedure to examine the safety or performance of the robotic assistant they are powered by language model or not. And then
Yeah, that's really interesting.
yeah, and the follow and one of the ongoing work we are working on now is to discover the safety issues, or developing a automatic safety or performance evaluation pipeline using red teaming on agentic agentic language model systems. For example, like a digital assistant, or like web agents or something like that. You can think of one threat in web agent is that the web agent will read the web pages, right? They will probably read the rendered web page, or maybe reading the source code of the web page. But either one can have some vulnerabilities, right? You can inject some malicious prompt into the source code of the web page, and your
Right.
web agent will read them and probably will reveal your identity or some personal
Right.
information to a third party. That's dangerous. And then if the model is reading the image from the web page, you could also try to craft some images that will trigger language model to do something malicious. Yeah.
Right.
So I think that's the new challenge of the safety in language model in agentic systems.
Right. Kind of these like
Yeah,
cybersecurity, quasi
cybersecurity.
cybersecurity.
Yeah.
I'm excited to read the paper that's already out and to stay up to date on this one that's coming out. Zhang-Wei, I appreciate your time. Thank you for talking to us about your work.
Okay. Yeah. Thanks.